Good afternoon. Welcome to the AWS Tips and Tricks session. My name is Oscar Cisneros, and I've been with Tableau for about a year. I came from AWS, and before AWS, I was with a company doing server migrations to the cloud. So all in all, I've been working with AWS technology for over 10 years, and I've been certified on AWS for over 5. My colleague here is Lee. I'm going to let him introduce himself.
Yeah. G'day, everyone. My name's Lee. I am a sales consultant based out of our Melbourne office. I've been with Tableau for on and off since 2015. In Australia, they call me a boomerang employee because I left and then came back again. And I wear a number of hats, but primarily I help with cloud stuff in my region, and I also am an embedded analytics SME for Australia and New Zealand as well. So we'll jump in. Today, we'll have enough time for questions, so if we want to hold them to the end, that's great. And we'll hang around afterwards for a moment to discuss as well, or I will. I think you've got somewhere to be.
All right.
But I'll get started. Let's see if this clicker works. Yeah, perfect. Okay. I should have had this slide up while we're introducing ourselves, but why are we here? So what are we going to talk about today? So this session is really to help you avoid some of the common challenges that I see customers run into when they're deploying on Amazon for sort of the first time, or they're getting started with Amazon. So this could be for experienced Tableau administrators. You've been using Tableau Server on-prem for a while and you're looking to migrate your deployment to AWS. Or it could be those of you that are just getting started for the very first time with Tableau or Amazon, and you'll be deploying on an EC2 instance. So what do we mean by tips and tricks? So this is really things that you will want to watch out for, like which instance size should I choose? What provides a good ratio between price and performance? How do we monitor Tableau Server in Amazon? What do we need to be aware of to get the most out of the licensing that we've purchased? How do I automate deployments or get started in that space? And so on. We'll start with compute today. And we don't have all of the topics up on this slide here, but this is just an overview. We'll talk about licensing, instance choice, then we'll talk about common networking challenges that we see. Most of the customers that we work with, most of them have on-prem infrastructure still, or on-prem data sources, on-prem authentication, and so on. Most of our customers aren't 100% cloud, so we'll talk a little bit about, at a high level, how do we handle those scenarios when we have data or auth that is still on-prem. We'll talk about automation at a high level today. We won't dive deep into automation. We have full 1 hour plus sessions on how to automate deployments using CloudFormation, which is directly after this session at 2:15. So I'm going to remind you again later. But if you really want to automate Tableau Server on Amazon, he's running the deep dive session right after this. And finally, we'll talk about monitoring, which is one of the most important things. The great thing about AWS is that you can start with a small instance and it can scale up and down as you need. But to do that effectively, you need to monitor and understand what your users are doing and what resources you're using. So we'll talk about a couple of ways that you can do that. So we'll start with compute. The basics. What are we trying to optimize for? And it's really CPU, disk, network to an extent, and also memory. We want to find the best combination for Tableau Server for your needs, and we want to help you understand how to evolve your Tableau Server deployment over time as well. It's rare for workloads to stay static. You might have, as the gentleman from Uber down here said before, he has a QA or dev test workload that he needs. What size server does he need for that? So our goal is to find the right combination and to give you some tools to help you do that. Here's a reminder, and I shouldn't have to say this, but I will. I know it's very basic, but this is the minimum recommended requirements for production. And I just underline production. So this is for production servers that you'll have real user workload on. 8 cores, 32 gigabytes of RAM, but Those of us in our team, in the pre-sales team, we generally recommend 64. And SSD is a disk. And we'll dive into each of these in more detail. But this is for production. So if you're running a test, you just want to throw a few users on, you can go smaller than this. But if you know you'll have material workload, start here. So which instance type is right for you? And all organizations use Tableau differently. In my region, I look after major banks, major postal service, and a major health insurer. And they all have different workloads on Tableau, and they all use it in different ways and drive wildly different numbers of users, types of workbooks, and they support very different sort of amounts of scale based on that usage. So everyone is different. Some of the things that drive your workload and the choice of instance are user load. So this is the most common one. How many users will we be loading up Tableau Server with? This isn't how many users that we have in total. Had a gentleman down here say that he accidentally added 80,000 people to Tableau Server. Not him, sorry, someone else in his team, or tangentially related to him. That doesn't count as load. It's only people that are concurrently using Tableau Server that counts as load. Workbook design counts, how many dashboards, how many sheets do I have on a dashboard? How many marks do I have on each sheet? How fast my data source is, how complex my calculations, and so on. These are the things you need to think about and understand because they drive load, and they're all interrelated. So the suggestion at a high level is to, if you're new to Tableau and you don't have an example workload to test against, you need to monitor. So use Tableau Server monitoring, we'll talk about this later, use your maybe CloudWatch or other tools that Amazon has for monitoring, to look for instances where your CPU is hitting its peak, where you're getting contention for CPU or memory, or not more importantly, but also importantly, when you're running out of disk. So is the latency increasing? Am I running out of GP2 burst balance, which we'll touch on shortly, and so on. And finally, drive workloads against your instances. If you know you're going to have 10 users or 100 users, use our load testing tools to drive it against different types of instances in Amazon. They spin them up for a few hours, run a test, benchmark it against different types, and understand what's going to be right for you. The good news is a lot of this has been done for you to help you pick a general purpose instance. And we have a white paper called Tableau at the Speed of EC2 that helps cover a number of these topics. Part of the white paper is a Tableau public visualization, which we've distilled down into a number of different charts. So this is a very basic chart here, but it's essentially a scatter plot showing price versus performance. And what we found in our own testing, and this is just a standard 8-core node with a workload that we consider to be fairly sort of representative of customers that we see, that C5 and M5 type instances provide a good balance between price and performance. There will be exceptions to this. I have a customer at the moment that has a very big hyper extract that they use extensively, and they will use a lot of memory to drive good performance. So they have shifted to using an R series instance, which has a lot more memory. This presentation will be available afterwards, and it links out to this Tableau public visualization, he says. There we go. It allows you to come in here and choose from the different scenarios that we processed, from 5 users all the way up to 320 concurrent users. So if you have an idea of, we think we're going to have roughly 100 or 80 concurrent users, you can come in here and pick a scenario that's close to how you think your load will look. And then we can adjust for different performance metrics, like percentiles for response time, error rates, transactions per second. Every request based on our load testing we call a transaction, to help you choose an instance type up front if you haven't deployed Tableau Server yet or you're not really sure where to start. And then as you hover over our different dots here, you'll get an estimate of the monthly cost, as well as the instance type and the average response time based on all of the tests that we've run as well. So this is a great visualization to help you understand how different instance types work with Tableau based on our own load testing with AWS. There are a number of different tabs in this workbook that dive even deeper. I really like the scatterplot one at the start because it really just helps me get an overview of where I should start. But we do dive into distributions for response time, for example, trends for response time, throughput limitations, so when does our throughput start to degrade? And throughput will spike, how many transactions can we serve per second will hit a peak before we have too many users and we get contention, and on average our transaction time will start to decline again. And failures as well. So different instance types for the same workload may have different failure profiles. And what I mean by a failure is, did the viz fail to load? Did a user action fail to complete, and so on? And sometimes that can be compute or CPU driven, and sometimes it can be memory driven. But again, this is just a great workbook to start to understand a lot of this stuff. And it's linked inside of this presentation, but if you want to look for it straight away, you can Google Tableau at the speed of EC2, and you'll find a link to the white paper and the Tableau public viz. All right. You can tell this is live because I've extended my screen. I can't see my own one. There we go. Perfect. Okay. Sorry. 1 second. Fingers crossed. Okay, perfect. All right. So how do we validate instance types? We have two key tools for this, and one is newer than the other. So the tool that we've had for a number of years now to help you validate your choice of instance is called TabJolt. TabJolt is a load testing tool, and TabJolt is good for taking one workload and running the same workload against another instance type. The thing to know about TabJolt, it's not a real-world representation of user load. In the real world, you don't generally have 100 users all smashing a viz at exactly the same second. But what that means is it's repeatable. So it's a benchmarking tool. So you can spin up an M5 for XL, run exactly the same test on that, and then spin up an R5.4XL, run exactly the same test again with the same workbooks, with the same users, with the same workload profile, and get a workbook at the end of that that tells you, this is my throughput, this is how long my visualizations took to load, these are the error rates, and so on. So this is a great tool for benchmarking different instances. So if you have to do an upgrade, you want to move to a new instance type or move down to a smaller one, TabJolt can help you validate that. Replayer is something that's relatively new compared to TabJolt. It allows you to grab the logs from an existing deployment. So if you've got an on-prem deployment of Tableau Server, you can take the logs from that Tableau Server deployment, run them through this replayer tool, and point it at your new deployment in Amazon, or same thing for different Amazon deployments, and run the same workload that your users have actually been doing. So it will replicate clicks against workbooks and give you a more realistic representation for load testing than a tool like TabJolt can. So it will, by its name, literally replicate workload or replay workload you've seen before. So this is a great real-world testing tool. While we talk about sizing, a quick recap on server license types. Do we have any customers in here on core licensing? Oh, wow, okay, more than I expected. Core licensing is a hardware-based license. For those of you unfamiliar with core, you may have started on user-based licensing. In core licensing, we size Tableau, or we restrict the licensing based on hardware capacity. So you're restricted by the number of CPUs that you can run Tableau on. Whereas with our user-based capacity, you're not bound by hardware. You can deploy Tableau on as many nodes as you want in order to meet the demand from your users. Now, why is this important, and why are we even talking about this here? Well, if you are a customer that is on core licensing, then you're bound to hardware, so you want to get the most out of your investment in that core licensing. So you need to know which instance is right, or what are the small things we need to watch out for. So the metric we want to test here is the way we measure cores on Tableau server. We end up with effectively a ratio that the vCPUs in AWS amount to 1 Tableau core as we measure them. And if you need to check this, you can simply run this WMIC command on Windows. I've only included the Windows one here. There's a KB link at the bottom of this article that will help you with the Linux version as well. But we measure the number of cores metric from this WMIC command. Now this is important because for customers that I see deploying initially on Tableau, on Amazon, they will often pick a 2XL type instance which has 8 vCPUs. Which makes sense, right? Because we talked earlier that our minimum production requirement is 8 CPUs. Pick the one on Amazon with 8. But because of the way we measure cores in Tableau, in Amazon we detect 16 vCPUs as 8 cores, and you can use this WMIC command to validate that if you do need to check. And again, this goes back to, if I've got a core license and I only have 8 cores of capacity, I want to make sure I'm paying for the instance on Amazon that gives me the most value from my license. Hi. The number returned there is what Windows reports as the number of cores, and that's what we use as the check. Hi. You can, but we generally don't recommend that you go below 8 cores on a single node. So 8 cores with a server running all of the different sort of processes, the gamut of processes that we have, we generally recommend 8 cores. In certain scenarios, if you're only running extracts only on a single node, you could do 4 cores, but we generally recommend a standard single node is 8 cores as a building block. Finally, a note on storage, and thankfully this storage is like so fast and so cheap these days that this is becoming I guess, less of a concern than it perhaps was in on-prem deployments. But we have a bit of a starting point here, and this comes from our services team who has these baseline recommendations of if you're deploying Tableau server, if it's a minimum production install, what are some sort of baselines or what are some sort of health checks that you want to do on the storage? And we want to be down in the sub 10 millisecond latency range. We want 100 MB of read-write performance, fairly standard to these days for a solid-state disk. And we want 50 gig of free space. Most of the customers that I work with are going much larger than 50 gig of free space, and I would recommend you do so as well. And AWS these days gives you a few different choices for hard drives. Please don't choose magnetic disk today for Tableau. Pick an SSD. The price differential is not great enough to warrant using anything except SSD. And the most common choice I see for deployment, and that we find is generally fine, is the general purpose type SSD. However, there's a bit of a note on this, and that is that general purpose SSDs have essentially a quota. So they provide I feel really awkward saying this with Amazon sitting in the front row. Hopefully I get it right. They provide a minimum level of performance based on the size of the disk. So if you purchase a 100 gigabyte disk, you multiply that, you get 3 IO of performance per gigabyte as a baseline performance. And then they provide you like a bucket of performance that you can burst from. And you can monitor the bucket, how full the bucket is of credits that you can burst from. And you do need to monitor this. If you have a disk that's a couple of 100 gigabytes for Tableau server, keep an eye on this bucket, because if it depletes, you will fall back to the baseline performance that drive provides. And performance of Tableau server will degrade quite heavily. So it's just something to be aware of. There is a metric in CloudWatch in AWS that lets you monitor this balance of credits. And if you don't want to worry about it at all, you can just deploy a general purpose disk or GP2 disk of 1 terabyte or larger, and you won't run out of credits because of the way that they're renewed, or the way that they're renewed in Amazon based on the size of the disk. Cool. Yo. Correct. That's what I'm saying. Yeah, sorry. I'll repeat the question for the recording. The question was, are we saying that with an 8-core Tableau server, 16 vCPUs will be recognized as 8? Yes, that's what we're saying. So if you're running your 8-core license on 8 vCPUs today, hopefully I just found you some more capacity. But always, I always validate anyway with WMIC because I'm paranoid, so you do have the option to validate what Tableau will recognize it as well. Thanks. All right, so let's talk about some high-level networking challenges that we run into. And these are the most common ones I see. We're not going to cover everything here, but just the common ones. And some of these might seem relatively simple, but the frequency at which I see them, even with enterprise customers in my region when they're deploying on Tableau, warrants that I put it into this presentation today. And the first one is this. How do I play this? I'm going to have to do. It's a bit of a challenge. There we go. I'm going to have neck pain after today. There we go. The first one that customers generally run into is this. They put their license in and click on Activate, and then it fails. It says Tableau couldn't activate. And it's fine, it gives you instructions. In the GUI, it will give you instructions on how to activate offline. If you're activating on the GUI, it will also tell you to go and check the logs, which will tell you it couldn't contact our licensing servers. And this is because, I just had to click. Tableau has 2 modes of activation. We have online, which is automatic in the sense that you only need to provide the license key, and Tableau server will talk back to HQ, check the license is valid, and apply that license to Tableau server. So it's basically hands-off after you've pasted the license in. The other option we have is offline, which requires you to manually download a file from Tableau server, copy it to somewhere with internet access, upload it to Tableau. They'll give you a file to download that you copy back, and it's a few steps of manual processing to activate Tableau server. Offline has the benefit that it allows you to activate machines that are air-gapped, or there's a policy to never allow internet access on the machines. However, I generally recommend early and often to all of my customers that you, at a minimum, whitelist our activation servers for Tableau server so that it can do an online activation. And the reason for this is, as my customers have matured with the cloud, they've wanted to move towards things like automated deployments, automated upgrades of Tableau servers, things like blue-green deployments, so they can do an upgrade over here and direct traffic to it and then destroy the old one, and it feels like there's never any downtime for upgrades. And all of these automation tasks are a lot easier when you have the ability to do an online activation. So if you're just deploying once, offline's not that hard, but if you are moving to a more cloud sort of centric model or more mature on the cloud and you want to do this automation, life is a lot easier if you have the ability to do an online activation because you can script it all and there's no manual intervention. We've probably all seen what it looks like when we activate successfully. There we go. When it activates successfully, it looks a lot better. You just get a little pop-up message. Easy way to fix this, just make sure that you've got our servers whitelisted. There's only a few of them, and they're up on our website as well, and the link for those servers you need to whitelist is in this presentation. Really common one. I included this one. Who in here installed Tableau before TSM came out? Who are the tab admin people? Right, okay. So I see this more in accounts that have been using Tableau since the tab admin days. Back in tab admin world, before we launched TSM, we would automatically configure the operating system firewall for you. But in the TSM world, we don't. And this is one of those things that if you're new to deploying on Amazon and you're maybe new to deploying Tableau server in general, I've seen overlooked a number of times. So Tableau server will no longer automatically set or open the firewall ports at the operating system level for you. It used to in the past, which is why I've included this here, but from recently we don't do this. The other thing to consider obviously is your Amazon security groups. Just make sure that you've whitelisted or unblocked your users internally from the networks they'll be coming from to access Tableau server. My next one is one of my favorite ones, because I've seen this in a few customers over time. And it's this, same visualization on the left and the right. But one of them has loaded maps and the other one hasn't. Identical viz, identical server. You can see the breadcrumbs up the top lead to the same place. But one of them, the map is blank, and the other one, the map has loaded. And this is actually related to Tableau Server. The reason maps get sort of broken, I'll just use the technical term that they're broken, is that maps load from the internet. Tableau Server does not have a repository of maps that it pulls from. They come from the internet. On the left is an example of what we call browser rendering. So the maps are actually rendered in the web browser. It's the user's web browser that is reaching out to our mapping servers and requesting the images. On the left is something called server-side rendering, and this is when Tableau Server inside of AWS or inside of your data center if you're still on-prem is the machine that is reaching out to our mapping servers and trying to pull the maps back. Tableau Server will, in 9 out of 10 cases, maybe more, do what's on the right, which is browser-based rendering. We render the viz in the browser, we render the map in the browser, and so on. But under certain conditions, we will have the scenario on the left where the Tableau Server will do the rendering for you and essentially surface images to the user. It feels the same, but it can cause this issue where if our mapping servers are not whitelisted on your Tableau Server environment, you'll have this weird experience that's hard to diagnose because for some users, maps will load, and for other users, maps will fail to load, and it can be quite difficult to diagnose. The easy way to fix this is whitelist our Mapbox servers. That means when it does fall back to server-side rendering, we'll load the visualization successfully with the map. With that, I will hand over to Eliaska to continue on with networking, talking about data sources.
All right, very good. Thanks. So I spoke with some of you earlier today before we started the session, and I see that we have people in all ranges of the process of moving from on-premises to the cloud. Some of you are already there, some of you are in the process of getting there, and some of you are planning or expecting to be there. So when we were thinking about the things that you would be interested to hear today, we decided to talk about how you're going to access your data sources. But one thing that I want to clarify is that except for the first case you're going to see, all of this that I'm going to explain applies also for not only when you're accessing data sources from your AWS environment to on-premise, but also when your users on-premise are accessing your Tableau server environment on AWS. So, for example, we wanted to start with what not to do, and then go over what we're going to do. So there's multiple ways that you can connect your AWS environment with on-premise, and as everything, there's multiple factors that are going to determine what works for you in your organization. And there's cost, performance, reliability, and just flat-out technology. So we wanted to first highlight the fact that technically you can open up access to your data sources that sit on-premise to your AWS environment, but that is not a good practice for security reasons more than anything. Those of you that are not IT admins are going to get a reaction from your IT admin if you ask to do that. Let's just leave it at that. And those of you that are IT admins are having a little bit of a heart attack right now. I apologize for that too. All right, so we can't access our data sources directly from AWS. It's effectively opening up our data sources, our databases to the internet. We don't want to do that. So what options do we have? Well, there's quite a few actually, and some of them can even be combined. So the first one I want to mention is Direct Connect. Direct Connect is, as the name implies, a physical connection between your on-premises network and the AWS network. It's literally a physical connection. They come in and install a cable on your network infrastructure that bypasses the internet and connects you straight to the AWS network. As you would expect, it's highly performant. It's a very fast connection. It's naturally more secure than going through the internet, right? I have seen organizations, though, that are still aware of the fact that, yes, you could call it a private connection between your on-premises and AWS, but you're still sharing network with other AWS customers, so there's still security concerns there. So it depends on your security requirements. I know that we have certain three-letter acronym people in the audience, and I'm looking at them right now. So I would think that you would consider that. So the one thing about Direct Connect, though, is that it has a higher cost than other options. So it's usually a good fit for enterprises that are interested in highly performant connection between on-premises and AWS. Now, Direct Connect can also be combined with other solutions. Did I go too fast? All right, I'm meant to be here. All right. So then, as Direct Connect is physical, there's also software-based solutions. And they're all using VPN technology. And as you know, VPN stands for Virtual Private Network. It's encrypting the traffic, the network traffic on the fly in a way that only the start point and the end point can understand the information that is being transmitted. There are multiple ways to implement VPN between your on-premise environment and AWS. The best practice for when you go to AWS is to take advantage of an AWS service that allows you to use the receiving end on the AWS environment as a service. You don't have to manage it. All you have to do is connect from your own premises using supported VPN technologies, and most VPN products are supported because they're based on standards. And then you connect to this AWS VPN service, and then all of your traffic is encrypted between the two environments. I want to highlight again, you can do this across the internet, or you can do this across Direct Connect. So you can combine Direct Connect with encryption in transit. And then there's other variations where you can do your own VPN connections, and you manage the end on your on-premise, and you also have an instance with the receiving end on your AWS environment. It's essentially the same. It's just that now you're managing both ends. It's a little bit more work for you. As far as reliability, the security level, it's the same. So you can combine all of these options. There's also the Cloud Hub, where you can have multiple locations of your own premises environment connect to a single point on your AWS environment, as opposed to having multiple one-to-one connections. And again, it depends on your needs, your budget, and your requirements. Now, as our implementations become more complex, they become a little more difficult to manage. One way to simplify managing multiple connections to multiple VPCs is to have a centralized VPC where you handle all of the permissions and all of the traffic connections allowed, including on-premises to AWS, but also between VPCs. And we call that a transit VPC, that star-like topology. It's called a transit VPC. Now, up until recently, it was just an architecture recommended by AWS as best practice. They've elevated that to a service now supported by AWS. It's essentially the same technology. It's just now that you get full support and documentation from AWS. It's still based on the same topology. You have multiple VPCs around this one transit VPC, and that transit VPC is running software from other vendors, Cisco and others. So it's essentially the same. They just packaged it in a way that you can deploy it a lot easier now. And then you can manage all of your network rules and all your connections from there. One thing to consider is that as you pay egress traffic from your VPCs, now for any pair of VPCs you're connecting in between, you're paying twice the egress traffic. So in other words, before, if you just had two VPCs, A and B, when A connected to B, you're paying a single instance of egress traffic. Now that A and B have to go first to the transit VPC, and from the transit VPC go to B, now you're paying twice that traffic. Just something to consider. With the kind of organizations that need this type of topology, it's usually not an issue. Again, the cost is not significant for the advantages that you get at this scale. All right. Lee is up with authentication.
Okay. Thanks, Eliaska. Let's talk about authentication. And what I'll start with is if you're deploying Tableau Server, and I guess you're not part of the IT team or you're not part of the team that's looking after authentication, probably ask the team that is, or try and find the team that is. A lot of the time, this authentication problem is already solved, and we don't want to reinvent the wheel. But really what we're trying to talk about here is the most common question I have historically got about deploying on the cloud is how do we integrate with AD? And this is not really a Tableau question, but we'll talk about it briefly in the context of Tableau, is I have an on-prem Active Directory, I want to put Tableau in the cloud or in Amazon, and I want to use that username and password that they already use to log into Tableau. This question is actually becoming less common for me, and I think the reason for this is because more and more people are adopting things like Okta, Ping, OneLogin, and other SAML services. And often a lot of organizations will already have these in place. So try and figure out if you've already got a authentication federation system or service that you can use. It just makes life a lot easier for everything. So what are some of the common solutions? You have managed AD in Amazon, you have their AD connector, you have their simple AD service. You could bring your own or build your own domain controller in Amazon if you really want to. Or you can use SAML. And if you have SAML, I just recommend using it. It makes things much easier for federating authentication because you sort of solve the problem once and then use that single sign-on service for everything. But if not, let's talk about it. The challenge we're trying to solve is I want to use my Tableau LAN credentials or my Tableau AD credentials to sign into my Tableau server environment, but my domain controller is on-prem. So how do we deal with this today? And Amazon has great documentation around this, and the two common services are, if you want to, you could build a domain controller in Amazon, create a secure connection with Direct Connect or with VPN and so forth if you wanted to, and extend your domain controller into the cloud. This will give you the desired effect. You will be able to sign in with your credentials. However, if you don't need to do this, you have the option to use Amazon's AD connector service, which provides essentially a gateway that you can redirect your requests for authentication to an on-prem domain controller without caching any information in the cloud. So these are the two common options. There are other options that are documented on Amazon's website, and we link out to these at the bottom of the slides, but the three that I really see common today are these two, and more common than both of them is some sort of federation service like an Okta or a OneLogin, a Ping, and so forth, federating authentication requests for an enterprise. Yep. Well, extending your AD would be paid because you would pay for an EC2 instance, and it's basically building your own DC in Amazon. So you would be paying for the resources that you consume from Amazon. and AD connector will have a cost to it as well. Yeah. All right, monitoring. So this is one of the most important aspects of running a successful Tableau server deployment. The great thing about Amazon, you can scale up and down, which means you need to monitor to know when you need to scale up and scale down. First thing I'll touch on really quickly, because I'm sure I'll get this question, is we don't currently support AWS auto-scaling groups for Tableau today. So I'll just get that out of the way. We don't support them yet, but we will talk about the other aspects of monitoring and automation in a moment. So we'll start with talking about how to monitor Tableau if you are the Tableau person in your enterprise. And then we'll dive into how to think about this if you're maybe on the IT side and not necessarily running Tableau day to day. And I'll start with the server management add-on, because this is a really powerful tool for diving deep into why Tableau is performing well or performing poorly. And it goes in 3 different streams. Manageability, so understanding which resources are being used. What are my users doing? How many VizQL sessions do I have? How long are my queries to Redshift taking? And so on. It goes really deep. It's pre-built to help you understand in a great amount of detail why Tableau server is running the way it is. There's also a content migration tool. A customer asked me earlier, how do I migrate my content from on-prem to AWS when my users are using both environments at the same time? Content migration tool helps you solve that. There's a scalability stream to the server management add-on. It allows you to offload your Tableau server Postgres repository, which is the repository inside of Tableau that stores metadata about users and workbooks and permissions and so on, and run that inside of AWS RDS. So that will take one more service off Tableau server, which means less resource consumption. It also allows you to integrate more deeply in the security part with Amazon services. So you can use AWS KMS to manage your encryption keys if you want to use extract encryption at rest, which is a new feature in 2019.3. The great thing about server management is it comes with all of this pre-built. You don't have to build anything yourself if you want to monitor Tableau server in really deep-grained detail or fine-grained detail. If you want to understand why was my user performance poor at one point, it's because it overlapped with a number of different background jobs that were running at the same time. I can understand that and I can adjust for it. Or maybe it was because I had a high number of concurrent users. Or maybe because my queries were taking a long time. These are all questions that I've used this tool to help me solve for my own customers. Now, what if you're not doing Tableau stuff every day? What if you're more on the IT side and you're supporting Tableau from an infrastructure or from an Amazon side? I like to use CloudWatch to monitor Tableau server, and out of the box it gives you the basics like CPU, disk, memory, and so on. And it also gives you that GP2 burst balance metric we talked about earlier, which to refresh is sort of a balance that you can use for burst capacity for GP2 type disks. And when that balance runs out, performance will degrade for that disk drive. So you do want to monitor that one. But what you can do in Amazon as well is use their service for monitoring logs. So you can use their CloudWatch log agent to read logs from Tableau server, forward them to CloudWatch, and then pass and search and build alerting and reporting around these logs. So a really basic example, maybe you could have CloudWatch monitor for when there's a spike in the number of failed logins and send you an SMS that something is going on. Or maybe it could send you an alert or an email or an SMS when average query time starts to increase out of control. These are the sort of things that you can use CloudWatch for because it's integrated into that ecosystem of alerting and communication that AWS has. A couple of examples. We can use CloudWatch very quickly to forward our Viz Portal logs to AWS and pass out successful and failed logins, track them over time, and this might be useful if you have a seam in your environment that you want to forward this onto as well. Security is really important these days. People want to monitor logins not just to machines and operating systems, but also to individual applications. So you can pass this data out, monitor it in CloudWatch, or forward it onto your SIEMs as well. You can also use CloudWatch to monitor queries. So here's a quick example. Taking the VizQL logs from Tableau server, I can see the worksheet, the averaged elapsed time for different queries on each worksheet passed out of the logs, and displayed in this Amazon dashboard here. So I can see my actual queries in real time forwarded to Amazon and passed out that were sent to Snowflake when I was interacting with dashboards. So this is a really cool service, very quick and easy to set up, and you can forward logs of your choosing and pass them and build alerting and different dashboards inside of AWS if your role is more to look after the AWS side of things and you won't be doing this sort of reporting or administering the actual Tableau server software on a day-to-day basis. All right, finally, onto automation. Yes? No, sorry. Sorry, thank you. The question was, do we have templates for CloudWatch? And I can't go back. Let's try again. For CloudWatch monitoring, no, we don't today, sorry. Yeah, I've just built these for these purposes today. But if you do want a copy of these, give me an email afterwards and I can send it across. Cool.
So are these things coming from VizQL logs?
So these ones here are coming from the VizQL logs. So specifically in the current version of Tableau, queries and runtime for queries, the source worksheet, the user that ran them as well, come from a log file called native API underscore VizQL ... And the source for the login information is a file called vizportal ... as well. So these are coming from two different logs. These are vizportal, the other ones are VizQL logs.
So you have logins and queries. Do you recommend any other CloudWatch methods?
So can you speak?
So you mentioned logins and
Yeah.
queries.
Yeah.
Do you recommend any other metric?
Logins and queries are two that I would be interested in monitoring. The other one is the Tableau server logs will actually keep track of how much memory and CPU Tableau thinks it is using and disk response time it thinks it has as well. Those are also good to record. And there's log entries from time to time that will tell you when Tableau server has detected an issue, like it's run out of memory and it's decided to forcibly restart different processes. That's called Server Resource Monitor. Those log entries would be useful to monitor as well to understand if there are major issues. But really, the things that my customers are often interested in is how fast are things going and are people having trouble getting onto Tableau server. So these are some of the good ones. Automating Tableau server deployments. So again, want to dive deeper than I get to here. I just sort of touched the surface. Adi Askar is running a deep dive on this afterwards. But essentially, where I recommend you start is with the Tableau Amazon or Tableau AWS quick starts that we have. So if you just Google Tableau AWS quick start, and there is a link on the next slide as well, when you download this deck, it will take you to a page on Amazon or a page on GitHub where the source code for this is stored with this image. And the way that the Tableau server automated deployments work for Amazon is essentially everything here is done through CloudFormation. So the infrastructure, the configuration of the infrastructure is CloudFormation. And once CloudFormation has stood the stack up, we fail over, we move over to the Tableau server automated installer, which is a Python wrapper to install Tableau automatically, and TSM to do post-installation configuration as well. So these are the three top-level components you need to be familiar with to automate deployments on Tableau server. If there's one of these components you probably want to be more comfortable with than the other ones, it's CloudFormation. CloudFormation is really the template that does most of the heavy lifting for automating deployments. So that's where I would say you want to have a high level or a level of comfort before you automate a Tableau server deployment. The core components, CloudFormation sets up the infrastructure. It also places the scripts and installs Python that we'll need later for the installation file on the machines as well, in the way that our templates are set up. And these are just templates that you can use as a way to learn how this works or extend for your own environment. Then the automated installer is a Python wrapper that installs Tableau server automatically. You just give it a couple of configuration files that say, I want to run this many services, this is my details for my administration user and my other secrets, like my activation key, and it will go away and install Tableau server automatically for you. And finally, if you are doing things such as migrating automatically or doing an automatic recovery after a failure, or you want to do a build of a new Tableau server environment and automatically restore a backup to bring all the content across, you will want to be familiar with TSM as well, because this is the tool that handles all of the post-installation configuration tasks, like, for example, doing a backup and restore. And finally, supporting tools for your automation. Now, if you are in the habit, like some customers are, of blue-green deployment, where you stand up a new version of a product, test that it's working effectively, and then flick over to that new version, you want to make sure that that new version works the same as the old one, and that there's no degradation in the performance, that workbooks load in the same way. There are tools to help you make sure that this is the case. Scout lets you validate workbooks act as they expected with Tableau Server. So you point Scout at Tableau Server, you give it a set of actions you'd like to run, and it captures performance and screenshots so you can understand if things will look the same after you do an upgrade. The other one is you want to make sure that performance looks the same. So you could use Replayer or TabJolt to make sure that after you've upgraded to a new version, or while you're testing your automated deployment, that you make sure that performance will look the same for your end users as well. Cool. And with that, I'll thank everyone for their time. To go deeper than we got to today, right after this session is the AWS CloudFormation for Server Deployment session, run by Adi Askar. So this will go into the sort of nuts and bolts of how do you do automated deployments on Amazon. On Friday, there is a session that goes deeper on monitoring and managing Tableau server deployments with the server management add-on, which I also think is a great session to follow up if you are the sort of Tableau server administrator responsible for managing the server environment. And finally, please make sure you complete a survey in the mobile app. If you loved this session, let us know. If you didn't like it, please let us know as well. We want to make sure that we have the best experience next year and the right sessions. So please, if you could take the time to let Adi Askar and I know how we went, it would be greatly appreciated.
And also, let us know if this is the type of content that you're looking for, what other type of content you want to see on conferences. We're starting this experiment of public cloud track of sessions, and it's a new muscle for Tableau. So we're going to be looking at it very carefully, making sure that we adjust it to your needs. So we really appreciate it. We're going to pay real attention to the feedback that you give us as far as, is this content correct? Is this the right level of depth in the content? What other subjects you're looking for? So all of that, we're eager to hear from you.
Other than that, thank you everyone for your time, and thanks for coming. See you around at the rest of TC.